I'm Patrick Brady, University of Wisconsin-Milwaukee, as was already said. I am part of the LIGO scientific collaboration and also part of the SCiMMA project. So just to give you a quick background, the LIGO is the US Gravitational Wave Observatory experiment. And there are 2 sites in North America where we have detectors. We're part of a broader organization that's now a nascent actual organization, the International Gravitational Wave Observatory Network, which we're unifying detectors in Italy, so Virgo and Cagra, and we're starting to actually try to share a common set of services and cyber infrastructure across those 3 projects, because we actually operate in unison for pretty much everything we do, except for the detector design, building, and operations. The compute model that we have is shown briefly here, and lack of time means I can't go into depth, but the basic idea is that we have a set of remote observatory facilities that are geographically distributed. They acquire data. The data then flows through a set of pathways to different tiered computing environments, all the way down, of course, to then desktops and laptops and et cetera that people run applications on. There are 2 pathways. There's a low latency pathway where we attempt to get the data from the observatories to the compute facilities in seconds, analyze, and then send out alerts of gravitational wave signals to the broader community. And then there's a bigger pathway whereby we move data for offline processing. The other project that I'm involved in is SCiMMA. It's a CI Institute conceptualization project. We've been at it for a couple of years and are almost ready with our final report on the conceptualization. It's a broad representation of institutions working together to understand and document the cyber infrastructure problems for multi-messenger astrophysics. This involves the integration of many facilities and in particular through a lot of individuals. So this slide was put together by Andy Howell and kind of points out how multi-messenger astronomy is done today. LIGO may, in a fairly structured way, identify a gravitational wave signal, and then astronomers around the world go into panic mode, whereby they then start to try and fill out forms, figure out who's at an observatory, how can they get time to take pictures of a particular region of the sky, how to communicate that quickly to others. And there's a lot of tools out there for all the pieces, but they often are not well integrated with each other. So now, I have got a brief sort of SCiMMA vision here, which is intended to just show, because all of this is very real time, what we recognize as one of the key pieces that we have to sort of get together first is a way in which messaging of all kinds can be efficiently communicated back and forth across all sorts of observatories. And so we've designed it's more or less a pub subsystem and built on top of Kafka called Hopscotch, and provide a standardized client for it that actually makes this type of communication easy and efficient. And this is part of the first step towards being able to do much more automated responses to multi-messenger astrophysics events. Now, I'll move straight on to the questions that were posed, and sort of try to go through them rather quickly, but I found myself writing an awful lot as I started. So, one CI problem that I'd like to solve at the moment, well, I think I see sustainability as one of our major things, major problems. We all talk about it, and we all know what infrastructure is and what cyber infrastructure needs to be, but the sustainability of cyber infrastructure is actually a fairly difficult problem. It needs to be continuously operated, maintained, and renewed. And if we look to large facilities, they're often running with incredibly lean cyber infrastructure teams. They fund basically the core things that they need to get scrape the top level benefits off what they do. And then the cyber infrastructure that tends to be needed by users often falls between the cracks, with individuals proposing to build some piece of software or system that has no real sustainability plan, and often the natural thoughts of sustainability through paid services and other things doesn't really work well within the research economy. So we have got a number of problems there. The other one, which I think most people will also know at the moment in terms of sustainability, is actually retention of staff. We clearly have a lot of competition for where people can work and get rewarded financially, certainly much better than in the research enterprise. And so we are still, I think, actually, we're probably only seeing the start of how bad that can get. Using shared services from the broader CI ecosystem, in LIGO, we've got a great deal of experience. We're nearly 20 years at this now. We started out with a kind of a fairly insular approach to the data analysis problem, but we quickly, through really individuals more than actually, at least initially, rather than through a concrete strategic plan, got connected to a number of opportunities. HT Condor was our first and it is our longest successful engagement. That was an example where the maturity of the software, even at the early days, was sufficient that users really saw the value right away, and therefore we were able to really engage and work with the HT Condor team, and it's been just a centerpiece of what we do ever since the early 2000s. Open Science Grid is an example of something that we have got a long-term multi-decade engagement with. We've got strong collaborative work now, both with individuals in the projects and also with the project more at a higher level, but it was really difficult. The immature technologies at the beginning, the usual problem of when you're sort of trying to invent something like Open Science Grid, you've got a lot of people with lots of ideas for what the right solution should be, and nothing is properly supported at the beginning, made it really very difficult for LIGO at the start. We just didn't have the personnel to sustain and manage the engagement. So, but I talk about it because it's an example of something that has been successful. We eventually did get some resources, the technology's matured, and now Open Science Grid provides services and software that we rely incredibly heavily on, and it would be much more costly if we had to try and do it ourselves. So it's a big success now. And you can continue on down the list. Authentication and authorization, we're connected into CI Logon. We engage then on cybersecurity issues through centers of excellence and so on. So I actually think things are good here, but the challenge really is you've got to have people, and this was mentioned already by Dan. We end up relying on a set of people who are doing 10 things instead of possibly 2 or 3, which is still overload, but at least in that case, it's just a lack of person power. Collaborations and sharing best practices, I would say, funnily enough, the biggest technical challenge we tend to have is still reinvention of the wheel. It's not done by the project CI teams, it actually tends to be done by users. And it happens a lot. And so what we find is that sometimes the ideas are actually really good, and it's really a nice piece of software. Other times it's a good idea, but the software is terrible and is not sustainable. And then a cost falls onto the facility to maintain that piece of software. So training and best practices for software development and uniform adoption of various tools and technologies, I think, is actually a core thing that we should invest in. And the Carpentries projects, for example, are very, very good at helping us to make progress there. I did want to highlight one other costly challenge where I think somehow sharing best practices or figuring this out across the major facility CI would be a really good thing. We all use Slack, Mattermost, GitHub, GitLab, Google Workspace, Office 365, whatever it is. And what we've encountered now is that we're sort of staring down the barrel of how do we make sure that we retain access to all of these services as licensing models change, costs change, and so on. And so the current approach for small projects is to kind of piece together the free personal versions, but that has big obstructions in terms of authentication, authorization, collaboration workflows, and so on. And so I really do think that it would be nice to have a solution to this that we could somehow solve it not n times or n squared times, but once, and know that we could get to those things. I'll quickly, I'm not going to say much about this. I think it's already been covered. It is a delicate balance for adopting new technologies. We often find that security considerations really drive end of life for software and services that we have, because the bottom line is we don't have enough people to develop a new improved system and manage a transition to it at the same time until it becomes just critical to do so. And that's really not a good way to live, but it is, again, the person power challenge that we have. Socio-technical challenges and how to solve them. I guess this is an interesting thing. We all have heard the hype around Agile for many years now, and we know that there are formal approaches to it and so on. What I've noticed within LIGO is that we've essentially used an agile development practice without having a formal framework that we adopt uniformly. And I actually think it would actually behoove us to invest some time into getting experts who understand some of these agile development practices, training our young researchers to use them. And in particular, the formality of certain roles in agile development practices is the piece that's missing. There are people who often take on the roles within LIGO for different projects, but they're not named in the same way. And so it isn't understood what the role is. But if you look at it, you can see that it's there. Again, I would say one thing I wanted to highlight for us is we found that GitLab has just helped to informally drive better agile practices within the collaboration. It's been it's incredibly important to us, and it's interesting to kind of just imagine the value here in terms of something like this tool. GitLab Ultimate is $99 per user per month. So for an organization our size, that'd be about 2.5 million a year if we had to pay for that level of licensing. They have a generous academic licensing plan, which we benefit from. So we actually do a self-hosted service, but we only have about 25% of an FTE to keep it going. And so you can see the discrepancy here between what we actually can put into something like hosting GitLab for ourselves and what it would nominally cost and the value that is taken out of GitLab. So this is actually, again, pointing to the fact that there's just not enough people in our systems to even use some of the tools that are out there. I wanted to finish a CI solution that I wanted to share is SCiMMA Hopscotch. You can go to the beta platform at hop.scimma.org and take a look at it. We've also got an analysis platform that, again, is all in beta. These are all prototypes. There's no long-term sustainability plan for them at the present time, which is a high-risk area. So I'll finish there.
Thanks, Patrick.